Dear students, today we are going to study matrices, which is very important topic in class 12th mathematics. Learning objectives of this video lecture are: understand what is a matrix, determine order of the matrix, differentiate between different types of matrices, construct matrices of given orders, equate two matrices. Suppose some data is given to you in the following manner. Class 12th has 3 sections. Class 12C has 17 girls. Class 12B has 19 girls. Class 12B has 11 boys. Class 12A has 13 girls. Class 12C has 14 boys. Class 12A has 21 boys. Don't you think that this data is very untidy and this is giving us very raw information? So how can we arrange it? So this is not at all the right way to introduce any data. So we should have some different way to arrange this data. How we can arrange this data? Suppose the data has been arranged as follows. Class 12A has 21 boys and 13 girls. Class 12B has 11 boys and 19 girls. Class 12C has 14 boys and 17 girls. The same data which is listed here can also be represented in the tabular form. So we can tabulate this data like this: boys and girls, section A, B, C, and the number of boys in each section, number of girls in each section. The same data can also be represented in other way, in which we are taking ABC section here, boys and girls, and these two columns have been made. So the same information, the same tabular data can be written in the form of these matrices. This square bracket form, that is called matrices. So these two matrices, like in the first case you have 2 rows and 3 columns, in the second case you have 3 rows and 2 columns. Both are representing matrices. So we can say that such arrangement of information is also called a matrix. A matrix is a rectangular array of numbers or functions. Array means arrangement. The numbers or functions are called elements of the matrix. Matrix is denoted by capital letter and its elements are denoted by small letters. Like these two matrices have been considered as matrix A and matrix B. The horizontal lines of the elements, these lines, they are called rows, and the vertical lines like this, they are called columns. So this matrix A has 2 rows and 3 columns. Similarly, matrix B has 3 rows and 2 columns. A matrix having m rows and n columns is called a matrix of order m by n. The number of elements in m by n ordered matrix is mn. That means you are going to multiply these two numbers to give this answer mn. So this matrix A, its order is 2 by 3. You can write this here as well. Similarly, order of this matrix is 3 by 2. So number of elements in A is 2 into 3, that is equal to 6. And similarly, number of elements in matrix B is also 6. So in general, if I wish to denote a matrix, if I wish to define it, this is represented as A is equal to Aij. Ij represents here the position of the element. M by n, that represents the order of the matrix A, where 1 and m are lower limit and upper limit of the I. Similarly, 1 less than equal to j, less than equal to n, these are giving us upper limit and lower limits of j, where I and j both belongs to set of natural numbers. So order of a matrix, this is matrix A. We have already studied about its order, 2 by 3. Its number of elements are 6. So let us identify that which positions of the matrix are. Like this matrix 21. This is in the first row and first column. So its name is A11. Similarly, A12, that is in the first row and second column. So this is matrix, this is element 11. Similarly, A13, the element number 13, that means it is in the first row and third column. Similarly, you can have for 21, 22, 23 as 13, 19 and 17. So let us do one question number 1 from exercise 3.1 of NCERT. So this is the matrix given to you and your questions are: find out the order of the matrix, the number of elements and write down these elements. So let us solve them one by one. So the order of the matrix is written by counting number of rows, which are 3 here, by number of columns. So count all the vertical lines, which are 4 here. So that becomes order of the matrix A. The next question is how many numbers are there. So multiply these 3 and 4, you'll get 12. So that becomes the number of elements. Now next question says find out the element number A13. That means go for the first row and third column. You'll get element 19. So that becomes the answer. Then 21, second row, first column. So that becomes 35. A33, third row and third column, which is -5. A24, second row and fourth column, which is 12. Then 23, that means 5/2. So these are the answers for this matrix A. So let us do this next question. If a matrix has 24 elements, what will be possible orders it can have? The second part says, what if it has 13 elements in all? So when matrix has 24 elements, so the possible orders are 1 by 24. Basically, we are going to write factors of 24. 2 by 12. Then we can have 3 by 8. Then we can have 4 by 6. After that, you can reverse the order of the numbers like this: 8 by 3, 12 by 2, 24 by 1. So these will be 8 different orders possible for this matrix. The second part says if the matrix has 13 elements, how many possible orders we can have? So since 13 is a prime number, so we can have just 2 factors, and that is why we can have just 2 possible orders, 1 by 13 and 13 by 1. So the next question is, can we construct matrices? If I am given order, if I am given a relationship, can I construct a matrix also? Yes, we can. This is the order 2 by 2 and this is the relationship I plus j whole square divided by 2. So since the matrix has order 2 by 2, we are going to have these 4 elements only. A11, put I is equal to 1 and j also equal to 1. Square it up, divide by 2. Solve it. 1 plus 1 is 2, 2 square is 4, divided by 2. It is giving us 2. Similarly, A12, I is 1, j is 2. Square divided by 2. It is giving us 9 by 2. Then comes A21, I is 2 here, j is 1. So you can square them. You are getting 9 by 2. Then the last element is A22. This is 2 plus 2 whole square divided by 2. This is 4 square, 16 by 2. It is 8. So if you have to write matrix, write down these numbers like this: 2, 9 by 2, 9 by 2 and 8. So this becomes matrix A of the required order 2 by 2 and using this formula for construction of its elements. One more question. That question comes under HOTS category. The number of all possible matrices of order 3 by 3 with each entry 0 or 1 is, you have to select the correct option. Number of elements is 3 by 3, that means total number of elements are 9 in all. Since each element can either be 0 or 1, so each element can be arranged in just 2 ways. So all the 9 elements can be arranged in 2 into 2 into 2, that is coming 9 times. That means it is 2 raised to power 9, that is 512 ways. So the number of all possible matrices of order 3 by 3 with each entry 0 or 1 is 512. That means this option D is correct. So next we are going to study types of matrices. We have different types of matrices depending upon their order or elements. So first is column matrix. A matrix having only one column, just single column, is known as column matrix. For example, a column matrix is represented by A is equal to Aij m by 1. It is going to have many rows but single column. For example, A is equal to 1, 2, 3 is a column matrix of order 3 by 1. It has 3 rows but single column. So next matrix is row matrix. A matrix having only one row is known as row matrix. So in general, a row matrix is represented as A is equal to Aij, 1 by n. 1 is the number of row, n is the column. For example, a matrix like this, 1, 2, 3 written horizontally is a row matrix of order 1 by 3. It has got 1 row but 3 columns. Next is square matrix. As we know, the speciality of square is it has length and breadth equal. So similarly, if we have number of rows equal to number of columns, it becomes a square matrix and its order is m by m or n by n, that depends. For example, if I take a matrix like this, 1, 2, 3, 4, it has 2 rows and 2 columns. So it is a square matrix of order 2 by 2. So Aij, if this is the matrix, we can also say that these elements 1 and 4 are known as diagonal elements. In the above matrix 1 and 4, only these two are considered to be diagonal elements, not 2 and 3. The next type of matrix is diagonal matrix. It is a square matrix in which all the non-diagonal elements are 0. In general, you can say that a square matrix A, Aij m by m, is a diagonal matrix if Aij is equal to 0 for all I not equal to j. For example, if I'll take this matrix A, the square matrix A having elements 1, 0, 0, 4. So these diagonal elements are 1 and 4 and non-diagonal elements are 0. So this is a matrix of order 2. Similarly, matrix B consisting of a single element 2 is also called as diagonal matrix of order 1. Let's move on to the next type, which is scalar matrix. Scalar matrix is also a type of diagonal matrix, but all the diagonal elements are to be same, they are to be equal. So square matrix A, Aij m by m will be a scalar matrix if Aij is equal to 0 for I not equal to j, but it will be a constant k when I is equal to j. K is a constant. That means k can belong to set of real numbers. For example, if I'll take matrix A to be 4, 0, 0, 4. So these diagonal elements are same, 4 and 4. So this is a scalar matrix of order 2, whereas B2 is a scalar matrix of order 1. So next type of matrix is identity matrix. This is a square matrix in which all the diagonal elements are 1, but all the non-diagonal elements are 0, and this is denoted by capital I. And subscript is order of the matrix I. In general, you can also say a square matrix A consisting of elements Aij of order n by n is an identity matrix if Aij, the elements are 0 for I not equal to j and they are 1 for I is equal to j. For example, A1001 is an identity matrix of order 2. So you can also denote it as I2. And B, just consisting of single element 1, is a scalar matrix of order 1. So you can also denote it as I1. If you are not writing that subscript with letter I, then also it is going to be workable because capital I stands for the identity matrix only. So next type of matrix is going to be zero matrix, which is also known as null matrix. A matrix of any order but whose elements are 0 is known as null matrix or zero matrix. It is denoted by capital letter O. And these are examples of the null matrices of different orders. This is for the order 2, this is for the order 1, and this is for the order 2 by 3. That depends on the situation and the question, whatever we require. So the next concept is equality of matrices. When can we say the two matrices are equal? So we have just two conditions, that they must have same order, and the second is their corresponding elements. Aij and Bij are also equal for all I and j. So for example, this matrix A, B, C, D and another matrix B, A, C, B, D are not equal. Why? They have same order, 2 by 2 each. But still they are not equal. Let's start comparing their corresponding elements A, B, C. So this element doesn't make equal. Similarly, this C and B, they are also not same. So that is why we can say that A and B are not equal. Similarly, C12 and D12, they are equal. Why equal? Because orders and corresponding elements both are same. So let us solve this question based on equality of matrices. We are given that these two matrices are equal. You are supposed to find the values of x, y and z. So if matrices are equal, that means their elements are also going to be equal. So we can have these equations in 2 or 3 variables x, y and z. Let's name them 1, 2 and 3. So can you solve these all three equations to get the values of x, y, z? How? Suppose let's take this equation 2, x plus z is 5. So let's use it in 1. Using equation number 2 in 1, we will get, replace x plus z by 5. So you will get y plus 5 is equal to 9. That means y is equal to 4. So you have got the value of y. Similarly, you can use third in 1. This will give you y plus z to be replaced by 7. So x plus 7 is equal to 9. That is giving you x is equal to 2. So you have got 2 values out of 3. So substitute anywhere. Let's take 1 only. So x is 2, y is 4 and z is to be calculated. This is giving us z is equal to 9 minus 6, which is 3. So you have got all 3 values of x, y and z. So let us summarize the entire session that we have studied so far. A matrix is a rectangular array of numbers or functions. The numbers or functions are called elements of the matrix. Matrix is denoted by capital letter and its elements are denoted by small letters. The horizontal lines are called rows and the vertical lines are called columns. A matrix having m rows and n columns is called a matrix of order m by n. The number of elements in m by n ordered matrix is m into n. You can multiply. A matrix consisting of a single column is known as column matrix. A matrix consisting of single row is known as row matrix. A matrix having same number of rows and columns is known as square matrix. A matrix having all non-diagonal elements 0 is called diagonal matrix. A diagonal matrix which is having all the diagonal elements same or equal is called scalar matrix. A square matrix having all the diagonal elements as 1 and non-diagonal elements as 0 is known as identity matrix. A matrix will become a null matrix if all the elements are 0. Two equal matrices will have the same order and the corresponding elements are also same. That is all for this video session. In the next video lecture, we will study more about matrices. Thank you everyone.